Okay, welcome to session 11. So we've got the recap, and then we're going to be looking at angles in regular polygons. So I'll do the normal, scroll through slowly, do the answers as well that way, so you can pause and play if you're working from the screen. If you're working from the workbook, then it's good to go. Okay. Okay, so here are your answers. So it's obviously, a lot of work. Use the workings out to help you if it has gone wrong at all. And yeah, it is a session, but it's so important that you are doing these recaps and not kind of skipping them, because they become quite big and they're a job all of their own, aren't they? So I will scroll through very slowly, and then we'll get going on the next bit of learning. Okay, so we are looking at regular polygons. Now, regular polygons is a tough one. It's at the top end of your angles for foundation. It's crossover, it's in both higher and foundation. And one of the reasons it can be quite tricky to learn is because it's not just a handful of rules or a particular formula or a couple of steps. Every question feels and looks different, so it is a tough one. You have to put a lot of trust in the facts, so the geometrical properties that you know. So we're going to learn about our regular polygons and what that means, but you'll find yourself using angles in triangles, in quadrilaterals, in straight lines, in vertically opposites, and angles around a point, and all these basics that you learnt with and built on will come into play into these types of questions. So being able to draw on all that information is what makes this quite tricky in places. So I'm going to give you all the information about regular polygons to start off with, and then we're going to do a handful of examples to get you going, but it really will just be a case of you just going for it and practicing. As I say, every question has a different feel to it, so it's quite a tough one to try and teach yourself, that's for sure. All right, so we are looking at a regular polygon. That is an 8-sided shape. It's an octagon, so it's a regular octagon. The difference between regular and irregular 8-sided shapes isn't their name. They're both octagons. It is the fact that the angles and the edges of regular shapes are equal. So they don't have to mark. So, for example, they don't have to mark all that to tell me that the edges are the same, because they've used the word regular, and I should know that that's what that word means. Equally, they don't have to try and tell me that all the angles inside are equal, because that word regular should be telling me that. So it's a real key word in the exam. And that regular, that word, really, you want to train yourself to get it to trigger a formula triangle. So 360 is going to go in the top. We've got sides, which I normally put just an S in, and exterior, which you could just put an E in, but we want to put the full words in at this stage because we're still learning about it. So our word regular needs to trigger that. And my advice would be to really make that link, writing it out every single time, because actually the formula triangle normally gets you into the problem. Okay. So why is it what it is? All right. I'm going to try and explain each element of that triangle for you. Now, if you were to imagine, I'm going to probably do it with a pentagon. It won't be a particularly brilliant pentagon, but it is a pentagon all the same. If I was to extend the edge all the way out in that direction, and then extend this one out and extend this one out, and almost like a Catherine wheel, do that all the way round, and I mark on these angles, what I've actually just drawn are my exterior angles. Okay. An exterior angle sits on a straight line with the interior angle. So that's a really important fact. It would feel much more natural to say that, okay, just in case your eyes weren't on the screen over here, that would feel like an exterior angle if you didn't know any better, because it's the outside angle. So it's quite natural and normal to think that until you're told something different. But the exterior and the interior will make that half moon, they're a straight line, they're 180 degrees. So that fact is pretty much used all over this topic, okay? Now, if I was to start shrinking and shrinking and shrinking that pentagon, so it was so small, it was nothing more than almost a little dot on the page, okay, because it's so small now, my eyes can no longer see it's a pentagon, it's just a dot on the page. The angles that I extended would still be sticking out, okay, creating angles around a circle. So the exterior angles will add together to make 360. And that is why you have this link here between the 360 and the exterior side, exterior angles, and while you've got the 360 and the sides connected. I've got 5 angles because I had a 5-sided shape. If I'd taken the octagon and stretched all those edges out and then shrunk it down, I'd have 8 lines coming out of a center point. So the side, the exterior, and the 360 are all linked because of that exterior angle creating the 360 degrees around a point. So that's how the formula triangle is what it is, okay? Now, the fact that regular has all the edges the same, so all edges are equal, that can lead to diagrams having a lot of sort of isosceles triangles, for example. So an isosceles triangle could easily crop up in this topic because we've got edges the same, and an isosceles triangle has 2 the same. Something like a parallelogram may come up because, again, that is got edges that are equal in length and that are parallel. Another thing that we tend to see a lot of are kites, okay, because there's a lot of symmetry within the kites, and because we've got equal bits here and here, and we've got equal bits here and here. So all these kind of geometrical facts can come into play when we are working in this particular topic, okay? Let's take a look at this. I think that's the easiest thing to do. That's a lot of information. I'll just do a very quick summary. The word regular will trigger this. This triangle is helping you out with angles, okay? The fact that all the edges are equal can lead to other shapes being created that have equal properties within them, like isosceles and kites and things like that. All right, let's go for our first example. So we're being asked to find the angle F and the angle E. So the question is going to, support the diagram, and it will say, you are looking at a regular shape, work out F and E. So the first thing that we are going to do is we're going to draw our formula triangle, 360, sides and exterior. We're then just going to count the number of sides our regular shape's got. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 360 divided by the sides, 8. So I've done this bit here. And then that will equal my exterior angle. So 360 divided by 8 is 45 degrees. Now, whilst you're learning this, and even when you're good at it, to be fair, that's good practice. Label what you've just done, because when you've got a multi-step question and you've got a lot of maths happening, it's really easy to forget what bits went with what. Always mark on your diagram as well, because that can help lead to you being able to see other things. So I now know that this exterior angle is 45 degrees. Okay. I also know that the exterior makes a straight line with the interior. So 180 take away 45 is going to equal 135 degrees. So that's 135 degrees. If that's 135 degrees, that is, because all the angles are equal in a regular polygon. So E is 45 degrees, F is 135 degrees. So that is a starting point for this topic and a way of demonstrating how to use that triangle to start giving, we had no angles given to us when we started working on that. And that's the difference between knowing how to get started and not knowing at all. Because if you don't know about that triangle, you haven't got any numbers. You've got nothing to actually get you going with that diagram. So if you don't have that triangle to fall on, you've got nothing to get you started. So it's absolutely key. So there's our next example. Oops, there we go. So a little bit more going on with this one. Still no numbers given to us. So again, we would have the word regular written in our story. And the first thing that we would do is draw in our triangle. So we're going to get our triangle drawn in first of all. What have we got? 360 sides and exterior. Okay. Now, sometimes if you just can't see anything in a diagram, it's quite good to just redraw it to the side. When you're completely stuck and you're not sure what you're doing, you could just redraw that. And as you draw it, you start to notice things. You start to notice, for example, that this line here has split the pentagon completely in half. Now, that might be useful. It might not be useful, but it's something that you're picking out of the diagram that may just be handy. And actually, if I think about it, that's doing exactly the same thing. It's just at a funny angle. That's splitting it exactly in half as well. So little things like that can be really useful. If you're redrawing it, then you can spot things like, well, there's a triangle. I know that the angles there are going to add up to 180. Or here's a quadrilateral. Things are starting to go on top of each other. Let's make that a bit easier to see. Here's a quadrilateral. Maybe that would be useful. So when you're looking at these diagrams, really, really be thinking to yourself, right, what am I looking at? Some of it will come in and be useful and some of it may not, but you're starting to digest as much as you can and think about that diagram. So my first thing is to look at the actual shape. It's a 5-sided shape. So I'm going to start off with my 360 divided by 5. So 360 divided by 5 is 72 degrees. Now remember, that's my exterior. So what I often do is I choose a different place on the diagram to put this information so that it doesn't crowd where I'm actually trying to go. I know that that is 72 degrees, and I know that is 108 degrees, because 180 take away 72 is 108. So I know these two facts, which means if that's 108, that is, and that is, and that is, and that is. So I have that piece of information to me. Obviously, I'm not near the C and the D, but I'm looking and I'm thinking about what else I know, okay? So I'm thinking here, if I've got a right angle on one side of the line, I have to have a right angle on another side of the line. Do you know what I'm going to do? I'm just going to change my color so things stand out a bit better. There we go. I know that's a right angle. I know that the whole of this shape here is 100, sorry, the whole of that angle there is 108 because it matches this one here, it's the interior. And I'm zooming in on the fact that I have got a quadrilateral where I know 3 of the angles, which means I am definitely going to be able to find my C. So I've got 108 degrees. Okay, I'm going to highlight in blue as I go. There's 108 degrees. I've got another 108 degrees there. So I've got plus 108 degrees, plus my right angle, okay, which is here. Now, when I add all of that together, so I've got 108, oops, I'm in the wrong menu on my calculator. Bear with me. My calculator's being a little bit silly. There we go. I'm usually quite quick at that. We get 306. Take that away from 360. And you've got your 54 degrees. Okay. So I now know that C is equal to 54 degrees, and I could mark it on if I want to up here as well. One of the other things that I would mention whilst we're just going through this one is you can see different routes around. So what I'm demonstrating to you right now is just really the way my brain has looked at that question and picked things out and pulled things together. There may have been an easier route. I don't necessarily always go straight to the easy route because I'm just following the way that my brain is thinking about this problem, and I'm not doing any more than that, okay? So there could have been a much easier way to get there than the way that I've just done it. And that is normal. There is no absolute correct way. Now, I'm going to show you something, okay? So we found C. I'm going to clean up the diagram and just pop on the information. In fact, let me not use such a big rubber and then I don't have to rewrite. So I just want to clean up kind of this bit here. I like the 108 and 72 because that's important. And I like the 54 because we don't actually know that that is 54 now. Okay. But I'm going to show you how you could have got that 54 way easier. Okay. So that was what my brain thought when it first looked at it. Now it's had a little bit of time, it can see an easier way. Okay. I know that the interior angle, so the whole of that angle there, I know that's 108. I've worked it out down here. I know it's 108. I know this is splitting it completely in half. I know that because of the right angle that they've given me. That is a perpendicular bisector. That means it's done it completely in half, which means I only have to do 108 divided by 2, and I can get my 54. That was it. That's all I actually needed to do to get C. It worked doing it this way. It wasn't the easiest way, but it did work. Okay. So for that reason, this line here is doing the exact same thing, isn't it? It's cutting an angle that is 108 into 2, which means that this here is 54 as well. Okay. Now I can use my angles in a triangle. So this is my triangle. Okay, I'm going to redraw it here. Not very well. These two are 54. So angles in a triangle add up to 180. Sorry, I couldn't get the last bit out of my mouth for some reason. So 54 plus 54 we know is 108. 180 take away 108 is 72. So actually it turns out that D is 72, the same actually as our exterior angle. And there's a lot of symmetry and things that does go on with regular shapes. So you can kind of see the same angles cropping up where you might not expect them. So that was a very long example, but it's a really important one because it does demonstrate the point that I'm trying to make. That you can go round the houses and still get the right answer, or you can spot something and boom, you can be there almost immediately. But there's no right or wrong way. As long as you're listing everything that you're doing down as you go, you're going to be getting all your marks. So it doesn't matter. You do what you see. You've just got to have something backing it up. You can't just guess that that splits it in half. You have to know that because of the right angle, it's split, and the fact that it's regular and it's got that symmetry, that it's going to work. So you can't guess your way around. You've got to use geometry to allow the decisions you make. But that is it. And that is why it's tricky, because the way you might think to move around could be completely different to the way that I would think to move around. And of course, you can't share easily what you've done. All right. All right, let's do another one. Okay, I think I might just bring that in a little bit bigger. So what I want you to do, now I know that you've only seen this once, you're probably not feeling hugely confident yet to be having a go on your own. And I'm not really going to completely leave you on your own either, but I wouldn't mind you just hitting that pause and just starting to take some time, look at that diagram. What sort of information can you get out of that diagram? What's the diagram trying to show you and tell you? Kind of make a little bit of a list, maybe even start. We know there's no numbers, and the only way to get numbers into that diagram is to use the formula triangle, the 360 sides and exterior. So with the limited amount of work that you have done so far, hit pause and play around with this diagram until you've had enough, and then come back to me and we will go through this, okay? Okay, so like I say, some of the things that you may have spotted or you may have done could be different to me. I'm just going to show you the way my brain has seen this, all right? So the first thing I'm doing is I'm counting the number of edges. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9-sided shape there. So I'm going to be doing 360 divided by 9. That gives me 40, which is my exterior. And I'm going to choose to mark this on. I could choose anywhere I like. I'm going to actually go over here just to start off with, because I'm not sure how I'm going to use it in the diagram yet, or what use it's going to have to me. It also means that I've got my exterior of 140. I'm not going to leave that without the maths, because I want my examiner to see that I know what I'm doing at every stage. So I've got those two pieces of information that could become really, really useful. What else can I see in this diagram? Well, they've done me a couple of dashes here, which means I'm definitely looking at an isosceles triangle. So that's good to know. If that's isosceles, because it's got one full length of that edge and then it goes to the center, okay? Anything that has that same look about it will have the same isosceles. If I look at this one and think, oh, this might be the same as well, actually, when I start to look at this part here, I don't have a nice straight edge. I'm right slap bang between two of them, okay? So that is definitely not the same as that. In fact, what I'm looking at here is a kite. And it's the properties of a kite that I can see will work now that I've identified it. So I know that this side has got to be 90 degrees, okay, because it's angles on a straight line. So it has to be 90 degrees. My kite, which I'm going to highlight, so it's really easy for us to follow, is here. And I actually know 3 of these angles already. Okay, so I'm going to just bring it out so it's really big and easy for us to see. Now, it's obviously not to scale, but it doesn't matter. I know that that and that are supposed to be right angles. I know that is E, and I know that, and I'll mark it actually on the diagram, that is an interior angle. That is an interior angle of this 9-sided shape. So I know that is 140. So I can find E by doing 360, take away 90 plus 90 plus 140. So that total taken away from the 360 is actually going to give me 40. So I know that E is equal to 40 degrees. Okay. Now I'm going to use the isosceles triangle. The reason that I'm moving into that isosceles is because for me, there's got to be a reason for them to have given us that, which means it makes sense to use it at the first opportunity I get. And the reason that I can now use it is because I know E. I know E is 40 degrees and vertically opposite angles are equal. So I know that is 40 degrees because of my vertically opposite. Now in an isosceles triangle, and I'll draw it the same, that means I've got 40 there. These two are going to be equal because of the isosceles rule. So I've got to do 180, take away 40, which is 140. I need to share this out between the 2 angles, and then that tells me that that angle and that angle there, they are 70 degrees. Okay. So I've got enough information now to help me find F. F here and the 70 here, they make together the interior angle, which is 140. 140 take away the 70 is going to give me 70. So I know that that is 70 degrees guaranteed through the workings that I did. And as I say, there are different routes around these diagrams. You will, if you're doing it right, get the same results. You just might do it in a different way. Okay, let's do another one. So again, what I want you to do with this question is to just kind of relax, think about what am I looking at? What's happening? What do I know? What can I see? Try and think about any bits of geometry that might fit with this diagram. And of course, we have no numbers. And with 0 numbers available to us, we can't even get started. So the first step has got to be the triangle. And you will find that this is true of all regular questions. The first step is always the triangle. So even if you get stuck after that, you've still got the first mark because you made the first right start to the question. So hit pause, have a really good play around with that diagram, and then hit play when you are ready to see how this one is working. Make it a little bit bigger. Okay, so we have got 360 and we've got our sides and our exterior. So how many edges do we have? So you count them up and you have got 10. So 360 divided by 10 is 36 degrees. Remember, that's the exterior. So like I say, I just tend to go somewhere away from where the main problem is, so it doesn't get in the way, but it gives me a chance of just being clear about what I've got to start me off. So those two angles are what I have to get me started. Remember, we show, oops, a daisy, not like that, we don't. We show the examiner how we get everything, okay? Easy not to. So somehow that has got to help me, okay? Every single interior angle is 144 degrees, every single one, which means that one there is 144 degrees. Okay, so I'm going to mark it on there in red. That is 144 degrees. The green regular polygon is identical. It's a 10-sided shape with all the same conditions, which means the inside of there is going to be 144 as well. So what I've got is this shape appearing where these two are both 144 degrees each. And due to, I've got to clean this up now so that you can see what I'm talking about. Due to the edges being equal, okay, it means that that edge there and that edge there is equal, and that edge there and that edge there is equal, okay. It's a rhombus. Opposite sides of rhombus are equal. So I know that this angle and this angle must be the same amount. I could think of it in a slightly different way if I didn't know that about a rhombus. I could say, well, if I stick a line straight across there, then I know I'm looking at two isosceles triangles, yeah, which means that these two must be equal for that reason. Once you've got that fact, then it's really simple to just finish it off, because you've got your 360, you're going to take away the two 144s, okay. So let me just do that. Sorry. Which is going to give me 72. And then that 72 has to be shared by the top and the bottom angle. So 72 divided by 2, which is going to come out to give us 36 degrees. So A is 36 degrees. Okay. Right, we do have one more question. There it is. So I want you to hit pause and press play when you are ready. Okay, it's like, this is the topic, sadly. Every diagram feels different, has a different, you know, kind of number of properties to be thinking about, and it's what makes it the grade 5 that it is. Okay, so let's take a little look at what we've got. First of all, we've got two pentagons, so we've got two regular pentagons. So the first thing that I could do is start working on that fact. So I've got my 360 divided by 5, which gives me my 72. Obviously that's my exterior. So for me, I would mark that on somewhere, and then I would mark on the interior. So 180 take away 72 is 108. And then I would look to see whether any of that information was going to be useful, which fortunately it is, near the angles that I want. So if this interior angle is 108, then this interior angle is going to be 108. And because that's a regular pentagon as well, that's going to be 108. So I've actually got two angles marked up that are really close to the A and the B that I want to find. Now, A is inside a triangle. Okay, so I've got a triangle here, which is isosceles, and I have to spot that for myself because this edge here and this edge here are equal. They are sides of the pentagon. So those sides are the same length, which means they are the same length for the triangle that it creates there. So I've got an isosceles triangle happening in that particular place. So why is that useful? It's useful because I know that this angle here is 108. It's the inside angle of my pentagon, which means this angle here must be 72. And if that one's 72, that one is 72 as well. So now I've got 72 plus 72, which is 144. 180, take away the 144, is 36. So A is equal to 36 degrees. So I have now got enough information to find B, because I've got angles around a point. So I've got my 36 here, 108, 108, and then my B, angles around a point. So to finish this off, I'm going to be doing 360, take away 108, and another 108, and the 36 that we had for A, which I'm going to quickly chuck in my calculator. Yes, which is equal to 108 degrees. All right, so B is equal to 108 degrees. I thought that's where my brain went, and I didn't want to write it down until I double checked in that calculator. So, like I say, I can't do much more than encourage you. I've demonstrated some different and some variety of diagrams. The worksheet that you've got to work on is pretty full on. I'm not going to lie to you. There's lots going on. I'll scroll through so slowly. So if you're working from the screen and you just want to, draw them out and work on them that way, you can. Obviously, they're in the workbook. If you're worried about working on them and then like really messing them up, which when you're learning is likely to happen, one of the things that you could do is, if you've got tracing paper or like baking sheets, sort of the greaseproof paper, that type of thing, what you could do is trace the shape and do lots of doodling on your tracing paper. And then when you've got a good idea of what you want to do, you could then work on the real thing. So that might be useful. Obviously, if you've got a printer, you'll be able to print it out as many times as you like. So just some ideas, I hope, to make life a little bit easier for you. So it's have a go, do your best. I've done the answers as detailed as I can, but what you have to remember is it's my way of moving around the diagram and not necessarily yours. And I really, really don't want you to feel like you are wrong if you've gone in a different direction to me. It might not take you to the answer, but it might not be wrong in what you spotted, if that makes sense. All right, so I am going to disappear. I'm going to scroll through everything, and then I'll see you next session. So well done on this one. It's a tough angles